The value of a variable can go from undefined to constant to non-constant. And when we combine two operands of a phi function, we use this table, and what it says is that here x and y are operands. Obviously, there can be any number of operands in a phi function, but we look at two operands at a time and accumulate the knowledge that we have learned. That means the right column here. So we start with the first two operands, and if an operand corresponds to a control flow graph edge which is not known to be executable, I mean, we don't think we have to consider that operand, then we ignore it and move on to the next operand of the phi function. But suppose we have two operands which both are expected to have been computed. Then if one of them is a non-constant, it doesn't matter what the other one is, the result, or meet, is non-constant, and obviously the same for y instead. If both are undefined, I mean unknown, then the result is unknown. If one of them is undefined and the other is a constant, then we interpret the combination of these two as that constant, and the same in the other direction. However, if both are constants and they are not the same constant, well, then it's a non-constant. And if both have the same constant, we take that, of course, as the value. When we have done that for two operands, we go on with the next operand. And in the end, we have the value of the phi function. When we evaluate an arithmetic operator, such as, say, plus, then if one of the operands is non-constant, then the result is non-constant. If one of the operands is undefined, then there is an error in the program for add, since we use a variable which is undefined, so that cannot be done. Otherwise, if we add x and y and they have constant values, then we obviously evaluate the add instruction with these constants as operands and produce a sum with which is a constant. Okay, and then we can propagate that. So let's look at the conditional branches, or actually unconditional branch at the beginning. So when we interpret a basic block and we end with an unconditional branch, or equivalently a go-to statement, then what we do is to note that we should interpret the edge which goes from this basic block to this basic block. What we will do is to have a work list of edges that we pick one at a time and interpret the destination basic block or vertex. Okay? If there is a conditional branch and we can evaluate at compile time in which direction we should branch. So here we are in vertex U and should either branch to V or to W. Since we can evaluate this, we only need to add the edge corresponding to the taken branch and ignore the other edge. Okay? if instead we don't know in which direction the branch is going, we have to put both edges. That means from U to V and from U to W on this work list of edges to interpret.